AstroBEAR is an advanced computational tool for simulating complex astrophysical flows. So the advanced part of AstroBEAR, what makes it advanced, is two things essentially. The first is the ability to simulate many different kinds of physics all at once. That's something we call multiphysics. The second part is what we call adaptive mesh refinement. And there, it's very simple to describe. Basically, what AstroBEAR does is it simulates a astrophysical situation like a collapsing cloud of gas in such a way that the resolution, its ability to finely follow any individual piece of the gas, changes as the flow changes. So if the gas cloud is collapsing, the resolution basically follows the cloud as it falls with it. And it can then ignore the parts outside the cloud because you don't really want to waste computational resources computing empty space.
In order to study these from a theory point of view, some of these energetic events in these very high temperature and very dense regions in space, you need to kind of have a kind of computer code to do it because the universe is three-dimensional. And it's not something you can just kind of write down equations on paper and solve yourself.
You know, you can't put a star in a lab. It's very difficult to study these high energy density physics, you know, in the laboratory. So you have these theories, basically, that try and explain snapshots, you know, that we see in space. So AstroBEAR basically grew out of a code called Bear Claw, which was developed by Soren Mutron at the University of North Carolina. In the redesign of AstroBEAR 2.0, we've basically taken the modules that were in AstroBEAR 1.0, but they've all been sort of redesigned. And so you have a code that's built from scratch by grad students, designed to be, you know, easy to use by other grad students.
I can have an undergraduate student come to me and wants to work on a computational problem, and I can give them this code, but then it's very easy for them to kind of set up problems to take like a star and put it onto the computational grid.
So over the years, more and more physics has been added to the basic computational fluid dynamic framework of AstroBEAR. Not only can AstroBEAR solve the equations that govern the most basic flow of a fluid, but it can also accurately model complex properties associated with the fluid, such as its self-gravity, or heating and cooling, or radiation processes. It is these additional physics that make a fluid dynamic code apt for solving astrophysical problems. So for instance, say you'd like to model the formation of a star. With the multiphysics capabilities of AstroBEAR, you can do this and much more.
With my research and research of all the other group members, we incorporate more physics to those equations. So for my research, I'm using non-equilibrium cooling. So that adds another level of complexity.
We do simulations of inertial confinement fusion experiments here at the Laser Lab. And we have our own radiation hydro code. It's a good code, but what it doesn't have and what AstroBEAR is important for is the ability to study problems where there's a high degree of mixing. AstroBEAR was able to offer not only some of the physics that we needed, but the ability to study a wide range of resolutions.
I think what is unique about what we've built here is that we've not only built a powerful code for simulating astrophysical phenomena, but we've also built a framework around it for collaboration and for new users to get into the code, understand how it's built, and to add to it.
So we have a wiki system, we have our ticket system, the blog, and we also have a forum. And we do provide trainings for users. So if you just go to our website, astrobear.ps.rochester.edu, you can figure out all these resources we provide for users.
The development of this kind of code in this area is usually a collaborative effort because I think we are not experts in everything. I think one of the reasons why we want to bring this code to the community is to sort of enhance this collaboration between us and all of the different groups across the world. And that could probably be very helpful to enhance the code and make the code even better.
But if we don't have the large computer, even if we have the code, we can't do the science. So it really requires two things. It requires the large computing system and the code that can effectively use that large computing system.
The development of this code could not have happened without the CERC. Having the machines here for us to be able to test the code, push the code to, to new limits, understand the limitations of the code and go beyond them, analyze them and diagnose what was going on, required having, easy availability availability to lots of processors.
It allows us to do something on 4,000 or 8,000 cores that we couldn't do on a laptop.
So for ourselves, we're getting to open up completely new windows in astrophysics using AstroBEAR. And now we have collaborations with groups across the country, actually across the world, and it's wonderful to see other people using the code to do their own research, taking it in entirely different directions. And so we are looking forward to more collaborations like that and being able to facilitate studies of astronomy that go in directions that we hadn't really thought of ourselves.